Okay, 6.0, review of angles, SOHCAHTOA, and the cast rule. So just as a review, rotational angles, these are created when a terminal arm is rotated about the origin. Okay, a terminal arm just means the arm that we're referencing, that we're talking about, okay? So what we would do is we'd always start on the positive x-axis, and our normal rotation is counterclockwise. Okay. A principal angle is the coterminal angle that is the smallest positive angle. So the principal angle is an angle on one rotation. Okay, so if you remember back in grade 11, we'd have 0, 90, 180, 270, and then 360. Okay, and then related acute angles. These are the angles measured from the horizontal, okay, and they are between 0 and 90 degrees. So, for example, this here would be the related acute. These have to be in quadrant 1. Given the following rotational angles, determine the principal and related acute angle. Okay, and state in which quadrant the following angles are located. So, A is 320 degrees. So we have 0, 90, 180, 270, and 360 as a comma. Okay, we know that 320 degrees is going to be somewhere in this quadrant. It's going to be somewhere between 270 degrees and 360 degrees. Okay, so this is quadrant 4. Now, we take our angle, okay, drawn from the origin, and we draw it up to the x-axis. I always call this like bow tie, because no matter what, we have to draw up or down to the x-axis. We're never going to draw to the y-axis. Never, ever. So no matter what, we're going to have a piece of this bow tie. Okay, so this is 320 degrees. So that is the principal angle. So principal angle is 320 degrees. That's fine. It's on one rotation. Principal angle is on 0 to 360. Now, related acute is on 0 to 90. So what we can do is we can take this angle, and what we're looking for is just this angle in here. So we can simply do related acute angle is going to be the 360 degrees minus 320 degrees. Okay? And we get 40 degrees is the related acute. Okay, next one. So negative 120 degrees. So when we have a negative angle, what we're doing is we're rotating clockwise. So we still start on this positive x-axis, but this time we're rotating clockwise. So this is going to be 0. This is going to be negative 90. This is going to be negative 180, negative 270, negative 360, if we were rotating that way. So we can draw negative 120 somewhere between negative 90 and negative 180. And then we can draw up to the x-axis. So we're focusing on this angle in here. So the principal angle needs to be in the first rotation. That means 0 to 360. Okay, we talked about that domain. So if we have negative 120 as our angle, what we want to do is we want to add one full rotation. So we want to add 360 degrees. And what we're going to do is we're going to actually get like a coterminal angle. And all that means is an angle with all the same properties. It's just on a different rotation of that circle. Now, the related acute angle, I would do this in positive values. So I would disregard these negatives and I would go 90, 180. Okay, so we know that our coming from the positive x-axis and doing our principal angle, this is actually going to be 240 degrees. So we would do 240 degrees minus the 180, and we would get 60 degrees would be this related acute angle in there. Okay, let's talk about these angles, okay, this related acute angle. So we have 4 quadrants, okay? We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, we always draw our triangles in this bow tie, okay, up or down to the x-axis. So we're always going to reference 0 degrees or 360 degrees, right? 0 and 360 are coterminal. That means that those angles are the same, just different in a different rotation of the circle, okay? And then 180 degrees over here. So what ends up happening is whatever the angle we're given, so if we're given a principal angle, in quadrant 1, the principal angle, like if the principal angle lies on quadrant 1, it's already acute, okay? So already acute, so just leave it. If the principal angle lies in quadrant 2, what we're going to do is we're essentially saying, okay, we only need this angle here. So we would take the full 180 and we would subtract the angle that we're given minus the principal angle. And then what that's going to do is it's going to give us the leftover of this acute angle. Okay, quadrant 3, we would take the let me do this in green, our actual angle, which would be this, and we would subtract the 180 to get what's left over. So principal angle minus the 180. And if we're in quadrant 4, we would take 360 degrees, which is the full rotation, and we would subtract our angle, which is this, so minus our principal angle, and then we would get what's left over, which is this angle, which is the difference. Okay, so going back up here, oh, and then this occurs in quadrant 3. Okay, let's talk about 480. First of all, our principal angle needs to be on the first rotation. So we would take 480 and we would subtract 1 full rotation, which is 360, and we are going to get 120 degrees. So our 120, if we label 0, 90, 180, our 120 degrees is going to be in this quadrant. Okay, it's going to be in quadrant 2. So let's talk about the related acute angle. We know that we're going to take 180 degrees, we're going to subtract our angle, and we're going to get what's left over. So related acute angle is going to be 180 minus 120, because 120 acts as our principal angle, right, on 0 to 360. And our related acute angle is then 60 degrees. Okay, now we're going to talk about the cast rule. So without using a calculator, we're going to determine if each of the quantities are positive or negative. So I'm actually going to draw these on one graph. Okay, so 0, 90, 180, 270, 360. So 230 degrees is going to lie somewhere here. So this here is 230 degrees. And if we label the cast rule starts in quadrant 4. Oops. C, A, S, C. Okay? So For 230 degrees, this is in the T quadrant, but we're dealing with sine, the ratio sine, so this is going to be a negative. So whatever the ratio is, whatever number over the number, it's going to be negative. Okay? B, tan 470. I'm going to find a principal angle. I don't like 470. Let's subtract the 360, one full rotation. And I get 110. So 110 is going to lie somewhere here. Oops, I don't have to draw like that. Okay, so this is 110 degrees, obviously equal to like 470. They're not equal, but they're coterminal, so they act the same, they have the same ratios, etc. So this is in quadrant 2, this is in the S quadrant, but we're dealing with tan, so our ratio is also going to be negative. Right? In the S quadrant, the only ratio that's positive is the sine ratio. Okay, and now C. Cos of negative 60. So let's find a principal angle. Negative 60 plus 360. We get 300 degrees. 300 degrees lies somewhere here. This is in the cos quadrant. Cos in the cos quadrant is positive. Okay. Trigonometric ratios. So, trig ratios, sine, cosine, and tangent. Okay. Sine is going to be opposite over hypotenuse. Cos is going to be adjacent over hypotenuse. And tan is going to be opposite over adjacent. We use trig ratios when we're dealing with right triangles. Trig ratios cannot be used with acute or obtuse triangles. Only right. Okay, so as a review from last year, the reciprocal trig ratios. Reciprocal kind of just means like to flip it. Okay, so instead of dealing with sine, if we're dealing with 1 over sine, which is also called cosecant, instead of doing opposite over hypotenuse, it's hypotenuse over opposite. Okay, cosine. If we're dealing with 1 over cosine, we're dealing with something called secant. So instead of dealing with adjacent over hypotenuse, our new equation is going to be a hypotenuse over adjacent. And tangent. We're dealing with 1 over tangent, which we call cotangent, and this one is going to be adjacent over opposite. So I wrote a couple steps for solving. First, what we're going to do is we want to solve for the related acute angle. Okay, then, and you can do this, for example, by using like the trig inverse the ratio. Okay, and then we can use the cast rule to find out which quadrant the angle lies in. And I would sketch this. So number 3 is like sketch the 2 angles where in the quadrants in which they lie. And then what we're going to do is we are going to, just like on the previous page, compare our angles to the 0, 180, or 360. Okay, and then I have just like the cheat note from the previous page. If it's in quadrant 1, you're taking directly whatever angle that is, that's the related acute angle. In quadrant 2, it's 180 minus related acute angle. In quadrant 3, it's 180 plus the related acute angle. And in quadrant 4, it is 360 minus the related acute angle. Okay, so take a look at example 3 and let's go through these steps. Determine 2 angles to the nearest degree between 0 and 360. So this is just the domain that it wants it on. That's 1 rotation associated with each of the following trig ratios. So let's solve for the related acute angle. So first, in order to solve for theta, I'm going to have to sine inverse the 0.29. Okay, make sure, so this is in degrees, because that would be our, like, what we want theta in, our angle. Okay, so we get 16.8, so let's round to 17 degrees. Okay, now, we're going to use the cast rule to find which quadrant the angle lies in. So sine is positive, because see how this is a positive ratio? This part is the ratio, and then this part is the angle. So sine is positive in CAST. Sine is positive here and here. Okay. All of the ratios are positive in the A quadrant. S is positive in the sine quadrant. This is 17 degrees. This is 17 degrees. So our theta 1 is going to be our 17 degrees. That's straightforward. That's one of our answers. And now our theta 2, well, this is quadrant 2. We're going to do the 180 minus the 17, and then we're going to get this angle here. Or sorry, 180 minus the, oh yes, related acute angle in order to get this full angle on the rotation. 180 minus 17, I get 163 degrees. And this is our theta 2. Okay, so there are two answers here. Just a reminder, on one full rotation, so between 0 and 360, each trig ratio, it doesn't matter if it's positive or negative, we will get two angles. So now we have tan theta equals -7/24. Okay, so I'm going to theta equals, we're going to tan inverse the -7/24. Okay, and I get -16.26. So let's go -16 degrees. So if we're actually talking about the related acute angle, -16 degrees would be here. Okay, this would be 16 degrees. If we drew this up, that would actually be our related acute angle. So calculating wise, if you want the related acute angle, you would just leave this negative sign out of it. If not, you'd have to draw it and be like, okay, -16, I'm going to take that as 16 degrees. Because no matter where we draw this triangle now, these all would be 16, for example. Okay, so, oops. Now, what we want to do is we want to say, okay, where is tan negative? So, CAST. Tan is positive in all and in the tan quadrant, the T quadrant. So tan is negative in the S quadrant and the C quadrant. So theta 1, this is 16 degrees. We know that we have to take 180 and we want to subtract 16 to get our actual angle. So 180 minus 16 degrees, we're going to get 164. And that's our theta 1. So now, the -16 degrees here, we're going to go, okay, this is our quadrant with like 360 degrees. So theta 2 equals 360. We're going to subtract the 16, and we're going to get 244 degrees. 344 degrees. So there's our theta 1, and there's our theta 2. Okay, C, cosecant theta equals -2.681. So what is cosecant theta? This is 1/sine theta. And cosecant theta and 1/sine theta is a direct substitution because those are equal. So it equals -2.681. we can't deal with cosecant in our calculators. So what we're going to do is we can take the reciprocal of the left. So then we get sine theta. And then we're going to take the reciprocal of the right. So we're going to put negative 2.681 over 1. And now we're dealing with 1 over negative 2.681. And that's it. And then we start. Okay, theta equals sine inverse of negative 1 over 2.681. And when we put that into our calculators, we get negative, let's go 22 degrees. So same idea, negative 22 degrees. We have a rotation clockwise. So this is going to be 22 degrees. Now let's talk about this. Where is sine? This number here is negative. Okay, where is sine negative? So CAST, sine is negative in the tan quadrant and in the cos quadrant. So let's go. Theta 1 equals, this is 22 degrees. We're going to have 180 plus 22 degrees. Theta 1 is 202. Okay. Theta 2 is going to be 360 minus 22 degrees. So theta 2 is going to be 338 degrees. Okay, secant theta equals 13 over 5. We're going to change this to 1 over cos theta equals 13 over 5. Okay, now we're going to take the reciprocal of both sides. We get cos theta equals 5 over 13. Okay, so what we want to do is we want to cos inverse the 5 over 13. I don't know why I put 15. That's wrong. Sorry. 5 over 13. And we get 67 degrees. This is definitely going to be the related acute angle because it's on the domain 0 to 90. Okay, so let's go ahead and draw 67 degrees. Yeah, let's do it. 67 degrees would be right here. Okay, so we're dealing with cos, and when cos is positive. So CAST. Cos is positive in this quadrant, the C quadrant, and the A quadrant. Okay, so theta 1 is going to be directly 67 degrees because it's in the A quadrant. And theta 2 is going to be 360 minus 67 degrees. So theta 2 is going to be 293 degrees. Okay, we just subtract those.